So I think that we can start with the presentation of the paper Conceptual Design of an Integrated Solution for Urban Logistics using Industry 4.0 Principles. So Bruno, can you share your screen? Maybe you need to be a presenter, or maybe you are already a presenter. Yes, you should be able to share your screen. Okay, and you can start. You have approximately 15 minutes for your presentation. Okay. And then we will have some minutes for questions. Please.
Okay, thank you. Hello everyone, my name is Bruno Machado and I am presenting our paper that is named Conceptual Design for an Integrated Solution for Urban Logistics using Industry 4.0 Principles. We can start here with our outline for this presentation, and we'll start with the research description and goals for the research. The main research objective is to propose a conceptual model of an integrated solution for urban logistics using the passenger transportation fleet and flow to deliver goods into city centers. The main motivation for this research was that the urban logistics is a recent topic, a recent concept, and the lately increasing and increasement of the e-commerce sector and last mile deliveries highlights the importance of a new environmental friendly transportation service. And improving this means that this service can improve the quality of life within the cities. The research as an approach was, firstly, we clarified the urban logistics concept. Secondly, we performed a brief literature review about the solutions that are being adopted worldwide on this topic. After that, we interviewed our key stakeholders to understand the requirements of such integrated solutions from their point of view. And with that input, we could develop a conceptual model for the integration solution according to their requirements. So now talking more about the urban logistics itself. Firstly, the concept. The urban logistics is a popular term to describe a subject concerned with activities of delivering and collecting goods in a town and city centers. It entails a process of transportation, handling, storage of goods, inventory management, waste, and home delivery service. All is on its scope, and it entails this process. It also involves private transportation companies, typically, with these dedicated fleets that are typically powered by fossil fuels that it can deploy the challenges that we are presenting next in this slide. We have here the challenges that urban logistics are facing currently, and they are four major challenges. The first one is the global population living on urban areas. In 1950, only 30% of global population was living on urban areas, but it is expected that on 2100, it reached 85% of the global population on such area. This is even more concerning regarding the business to consumer e-commerce sales. In 2019, $3.5 trillion was made on this sector, and it is expected to reach $6.5 trillion in. The third challenge is the increasing number of small orders to be collected and are delivered to the large number of customers concentrated in some areas within the city, and this highly affect the optimization of daily load, to the city. And the lastly, but not the least important challenge that we have on this topic is that there are two kinds of stakeholders, two kinds of stakeholders in this topic. For example, the local government and the residents in the cities, they are mainly concerned on sustainability of the city and quality of life. So they are interested in this topic because of it. But we, on the other hand, we have the customers, the suppliers, the distribution companies that they are concerned about reducing costs and increasing efficiency of their operations. So we have here two different objectives, and it is challenge the topic and the results itself. Okay, now we're going to talk more about our proposal for the from this paper, that is the integrated solution that we are talking about. And for a briefing introduction, let me talk on the major flows that we have on the city. We have the passenger transportation flow, the goods transportation flow, and the particle transportation flow. This is the major ones. Obviously, we have others, but this is the major ones that we have on the city. And what we want to present and propose here is to integrate these two of them and use the capacity that is available on the bus, on taxis, and so on, to transport the small orders, and can reduce the number of trucks that are dedicated to transport one or two, whatever, orders to the customers. What are our goals with this solution? Our goal is to propose a new service of good transportation within the cities, create an intelligent system in urban logistics to support the decision-making process in real time, and guarantee efficient urban logistics service and environment friendly. This is our drives for these solutions. This little picture here is an illustration of our solution. Imagine here a city center with its network, bus network, to service the city. And imagine if you have a order to be delivered to the city center. We don't want a truck directly dedicated to deliver that order within the city. Instead of that, our solution proposes that this order is transported to a bus hub, and then the order is transported within the bus to the bus stop that is nearest to the final destination. When the order arrives the bus stop, the last mile operator collects the order from the bus stop and delivers to the final destination. This, our last mile operator, has to be synchronized with all the process, and is a last mile operator that only works with environmentally friendly vehicles. Okay, this is the process that I have mentioned. It starts with a request release by the by our customer, then puts the order on bus hub to be assigned to a bus to be transported. The bus transports the order to a bus stop that is nearest to the final destination, and then our last mile, our partner, a stakeholder, very important on this project, such other ones, but this one has to be on the bus stop to collect the order, and then deliver the order to the final destination, to the final customer that is the order. Okay, this is, so we can see here our global overview of the solution that I have mentioned. And with that idea, with its solution, we developed a concept model for the development of this solution itself. So we could start with hearing the requirements for our stakeholders, and we perform this diagram. This is a use case diagram that illustrate the functional requirements of the solution. We have here our system represented by this square, and our actors with these little boys here, actors on the system. The action formed by the white ones represent actions that are performed by the respective actor themselves. So what we want here to this solution to accomplish here is the customer start with request and order quotation. the system automatically calculates the quotation based on the address of destination and informs the customer of the value of these order quotations. And then the customer has to decide if he wants to register the order or not. If he wants to register the order, the system determines the order plan and informs the plan to the customer, and the customer has to confirm the order. If he's okay with the plan, he confirms the order, and the system automatically creates a notification to send to our actors on the process, these ones, about the plan to the order, about the timings, about the locations. Everything goes on these notifications, and then the customer knows where to deliver, which is the bus that he has to deliver the order, and so he registers the check-in of the order on that bus hub, and the system notifies the last mile operator to inform them what is the bus that is being transported the order. So the urban transporter, our driver on the bus, interacts with the system if in case of everything goes wrong, in case of failure of the bus or everything goes wrong in the process, he reports disruptions. Otherwise, the order arrives to the bus stop that must be unloaded, and on that timing, the last mile operator is there to unload the order, and he starts to register the order. The bus, he notifies the final customer that is already on last mile operator to prepare for receiving the order. And when the last mile operator arrives at the final destination, it registers the checkout from this vehicle, and the final customer confirms the order received on their final destination. This is our major process, and this is based on functional requirements that we heard from our stakeholders. Now, we wanted to put some Industry 4.0 principles on this solution. So we also developed another use case diagram, but this one is mainly focused on interface of orders with the bus. Basically, it is an intelligent process of check-in and check-out of the orders from and by the bus. What we want here is the digitalization of all the process with paper-free on the process. So we want everything on automatically during the process. It starts with our driver on the bus opens the trunk of the bus to put the transporter. The driver then puts the order into available slot, and the system registers the check-in, the start of this journey, and after that the driver closes the trunk of the bus, and the system has everything that he needs to register the check-in on the bus on the slot to inform the last mile operator. With that information, the last mile operator will be on the bus stop on the moment that the bus arrives, and he opens the trunk of the bus with his card or finger, for example, and the system authenticates the last mile operator. Then he picks up the order from the slot, and the system registers the checkout, and then he closes the trunk of the bus. On the bus stop, he closes the trunk of the bus, and the system registers the check-in of the order into the respective last mile vehicle, and informs the final customer about this process. Okay, this is our process of check-in and check-out in detail that we wanted to present. Now we're going to talk more about the results and conclusions of this study. And the main results of this study was a behavioral and structural modeling of the system documented by UML use case diagrams. The conceptual design provided a better understanding for us about the real problem, defining the actors on the system their relationships, and the limitations of their actions. This conceptual also describes how the interface with the IT system should be performed to answer the stakeholders' requirements. This study has clear limitations that we are aware of. We are aware that the next steps of this work, and we are working on that. This is a larger project that we are working, and we also have further studies and further plans to do, but the next steps are requiring to test and validate the conceptual design system proposed, and we have a pilot to do that planned on the next year to implement in the near future to test this. Now I am open to your questions. Thank you.
Thank you for your presentation. So, is there any question from the audience? It seems that we have no questions from the audience. Just
hello?
Oh, well?
Hello?
Hello.
Yeah.
Yes, can I ask you a question? If you go to your requirements, please, the requirements, the use case, just the diagram, please.
Sorry, didn't understand the question.
Are you able to show the diagram?
Yeah.
To share the diagram?
Mm-hmm. The first one or the second one?
The first one, yeah. So my question is this, you have the customer there and the sender, then you have the final customer. Isn't there a relationship between the two?
This one?
Yeah, the customer and the final customer. Shouldn't you show a relationship between the two?
No, because
they have inherited. Yeah, sorry, go on.
On our solution, we have our internal customer and our sender that wants to deliver some order to their customer. Okay, so that's why we have here our customer, our internal customer, that is a customer of our service, and the order as a final customer itself. So that's why the final customer is here. It's totally different persons, the people. Sorry.
Yeah, no, I understand, but it's a final customer, not a customer.
Yeah.
So yeah, they should be related. There should be a relationship in the diagram. I think. Yeah.
Sorry.
So
Sorry.
There should be, if you look at use case systems, as long as they are customer, then you are saying you have different types of customers, and that should reflect on your diagram. So you need to have a relationship between the customers, your internal customer, your final customer, and those be linked to the customer. Unless, of course, they are not going to be required to do all those things like request other quotation. So your final customer cannot request other quotation, for example.
Yeah, but the quotation is this quotation is applied to our customer internal, not to the final.
Okay, so I think you will need to make a to differentiate it and make it clear that it's an internal customer. And I think you then need a diagram at the top that says customer, and then you then branch it down to internal customer and final customer.
Okay.
Then I think it will be clearer, I think.
Okay, thank you for the input.
Right. Well, I suppose that the diagram will probably be, let's say, finalized when you will apply it to a real case. You mentioned that you plan a real implementation, so probably the diagram can be finalized when you will apply it to a real case.
Yeah.
Okay, so thank you again.
Thank you. Thank you.
And I think that if there are no further questions, we can move to the second presentation. The second paper is Review and Analysis of Blockchain Projects in Supply Chain Management. The presenter is Fabian Dietrich. Fabian, I can see your screen, so it seems that
Perfect.
all is working well.
All right.
Okay.
Can you also hear me?
We can also hear you, and
can you see me?
I can't see you actually. I
Really?
still see Bruno.
All right, let me.
Oh, okay.
All
Well,
right. At least I turned on the camera, but
yeah, the camera is turned. Okay, I can see you
okay.
now.
Yeah.
Okay. So you have 50 minutes for your presentation, and you are allowed to start. Thank you.
All right, thank you. I have the honor today to present our paper with the title Review and Analysis of Blockchain Projects in Supply Chain Management. My name is Fabian Dietrich, and I would also like to thank on the behalf of the whole team, the organization of the ISM conference. Actually, it's my first conference carried out in Microsoft Teams, and it works quite well. I'm very happy with it, so thank you for the organization. Let's jump right into the paper. So this is my table of contents. I will introduce myself very briefly in the beginning, then I will introduce the work and also related works. I will tell something about the methodology used in this paper, and then I will show the results of blockchain projects in supply chain management, so a kind of a summary of our review. And then we go a bit deeper and into an analysis of complex blockchain mapping approaches. And of course, I will end with a short conclusion and some recommendations for further research. So yeah, this is me, Fabian Dietrich. I'm from Germany and currently doing my PhD studies at Stellenbosch University and also working as research assistant at the ESB Business School, having 2 masters, one from the German ESB Business School and one from Stellenbosch University. So let's talk a little bit about where this paper comes from, or what is the aim of this paper. So what we have is currently a growing interest of customers, governments, non-governmental organizations in having a greater transparency throughout the supply chains. At the same time, we have globalization making it more complex, especially the supply chains, globalized supply chains, making it more difficult to increase the transparency or even to have transparency throughout the supply chains. And this lack of transparency increases also the probability of counterfeit components being introduced into a supply chain. And also, even before blockchain approaches came up, there were some authors mentioned solve these transparency and sustainability problems of globalized supply chains. And in this world, we have quite much literature, publications, projects, and so on, talking about the utilization of blockchain technology to overcome transparency challenges in supply chains. And the aim of this paper was simply to capture the current scientific state of the art, to identify present research gaps, and in particular regarding the part complexity to be mapped on the blockchain. But I will talk a little bit more about that in the next slides. So what we used here is a semi-systematic literature review to identify the knowledge gaps. We started with a keyword search. Actually, they were quite rough, the keywords, because we did not want that any literature is excluded simply because of missing keywords. So it's just supply chain management, blockchain technology, and smart contracts. As literature databases, we used IEEE Explore, Springer Publishing, China academic journals, because we have had also support from a Chinese student. And then, of course, the library of Stellenbosch University and the library of Reutlingen University. And the outcome was that we had in total 43 publications with advanced project maturity that was kind of good enough and qualified enough to be able to be classified regarding our criteria. So here you can see some of the terms we used for the classification. I don't want to read everything because it's way too much, but just in case later there are questions, here are all the terms on this slide. But it was quite interesting because we wanted to investigate also the complexity mapped on the blockchain. So I think the part here is maybe important to understand for the next slides. So we wanted to see, do they map single parts in the literature? And single parts refer mainly to a category that do not reach their module. but they do not their modular composition. And complex parts, however, they can experience modular changes in their modular composition, so they can include assembling processes. And if they were included in the papers, we would also categorize them and analyze them. So this is kind of important, the difference between single parts and complex parts. So here, a short overview. Our results, as you can see, the food supply chain is the most dominant supply chain or industry. So 22 publications refer to food supply chains or the food industry, followed by the automotive industry and a production environment with 8 papers. And what is also quite interesting, but this is more like a confirmation, I would say, because as you can see here, 33 papers deal with transparency as their main aim, as their main project aim. So this kind of confirms what I already mentioned on the first slides, that transparency is a huge driver of blockchain projects in supply chain management. And now when we take a look at the part complexity, as we can see, 36 papers, they deal with single parts, and only 7 papers deal with the mapping of complex parts. So only 7 papers deal with the mapping of modular compositional changes. And these papers we wanted to investigate more detail because we wanted to see like what are the characteristics of such complex approaches. So as you can see here, this is now a list of all the papers dealing with complex manufacturing processes or complex assembling processes. And as you can already see, like none of these 7 papers deal with a holistic picture. So they all lack somewhere. I would say that the most difficult part to map on the blockchain is the transformation from raw material into intermediate components or into final products. And this is simply because the raw materials, they have so different characteristics compared to, for example, a final product. And this comes mainly from the ability that raw materials you can split into smaller units. And this makes it much harder to create a holistic picture. And as you can see here in the food supply chain, they kind of can skip this point. So we would say that the food supply chain deals more with a kind of a blending problem. So they kind of have raw materials and they blend them together to a final product. So they can kind of skip this intermediate component aspect. So when we choose one here, which is then it's the last one. Lacks in mapping transformation events. So this is kind of the most holistic one. And so this one we analyzed more detailed because we wanted to know, does it still have some weaknesses, or is it probably an architecture that is suitable for a major part of complex supply chains. And I want to show you now that, like, I wanted to make it very briefly, but I hope that it helps to understand this one. It's an approach by Westerkamp, and it deals with tokenizing of assets. So he creates tokens here, and what is quite important in this aspect, they're not logically coupled. And I would like to explain what this means. As you can see here, in this approach, it works like this, that every part in the physical world is represented by a token contract in the blockchain. So A is represented by A star, B is represented by B star. And now when we have assembling processes, these are reflected by merging processes in the blockchain. So A and B is represented by a token contract AB star, and this includes a recipe. So this is quite essential in this approach. It includes a recipe that you must own the token contracts or the tokens of A star and B star in order to produce AB star. And these tokens then are simply marked as used, but there is no logical link to these token. So you kind of, it's very hard then to track and trace these token after they have been merged. So this is also one of the key challenges in this approach, and also a problem because the main aspect why we want to have the blockchain technology in supply chain management is to increase the transparency. And of course, this is a problem when it's suddenly hard to trace back and to create auditability after the tokens have been merged. And another aspect, this is also a major challenge in this approach, that every time when we have changes, it results in a redeployment. So I wanted to show this just to have a picture how this works. So in case A becomes now A2, as you can see here, we also have to deploy a new token contract. It's called then A2 star, and the old one becomes invalid. However, it remains on the system, but we have to redeploy a new token contract. This is the essence of this problem. And now when we have an assembling processes, as you can see, AB star is also not valid anymore, because we need now here a new contract as well. The old one becomes invalid, and the new contract and the new token must include in the recipe A2 star and B star. I know this is quite difficult probably to understand, but the essence of it, just to break it down, is that whenever we have a change at the very beginning of our supply chain, for example, like at the raw materials or somewhere, whenever we have a change there, it affects everything coming after this. And this is extremely difficult to Industry 4.0, we are talking about customization and things like this. So our supply chains become more dynamic. And with this approach, it's a huge challenge, or maybe even impossible, to maintain the mapping of a supply chain, of a complex supply chain. So now, when we concluded and summarize everything, we can say that the blockchain technology is used in the supply chain management of various industries, and thereby the main objective is to increase supply chain transparency. Especially in simpler supply chains, such as the food supply chains, we can already map the complete supply chains. Just because the products are already so much simpler, it's possible to just track and trace the final product. So this could be a reason why food supply chains take a major part of supply chain related blockchain projects. But however, in supply chains dealing with complex part, currently no solution exists which enables the mapping of assembling processes, an efficient auditability of all assets, and also an implementation of dynamic adjustments. So the recommendations for the future, one aspect that we did not deal with in this research was that there could be also other aspects limiting blockchain applications, especially in complex manufacturing supply chains. For example, the scalability of the blockchain technology, or there could be other reasons. It doesn't have to be because there is no available architecture. So this must be considered in further research. And also we believe that a holistic smart contract based architecture could represent a very important milestone in making these characteristics of the blockchain technology accessible to complex manufacturing networks, and they could allow manufacturing networks with assembling processes to use the blockchain technology to increase the transparency in their supply chains. Yeah, this was the presentation. Thank you for your attention. In case you have any questions, feel free to ask. I know this is not our most innovative paper. However, I think it's a very important one because it reflects the state of the art, and it presents the research gaps. And it's very interesting also to see like how far is the research in terms of mapping complex supply chains. Thank you for your attention.
Thank you, Fabian. So we have some minutes for questions. Yes, I can see a request, I suppose, for intervention.
Hello, Fabian.
Yes.
Thank you for your presentation. That's
you.
quite good. If you don't mind, can you clarify, if you go to your last, the slide before this,
Yes.
What do you mean by holistic smart contract?
Okay, this refers to this aspect, what we have here. So I would consider something holistic when it's able to cover all these aspects. As you can see here, like currently this is not the case. Every approach, every architecture lacks somewhere, and a holistic one would allow the mapping of the transformation from raw materials to intermediate components to final products, and also include the mapping of transformation events. This is everything that happens in a supply chain, and this is what we consider a holistic smart contract.
Okay, thank you. It's a bit much extended than that. That's what I want to clarify. Because
yes.
if you talk about circular supply chain management, then the holistic picture extends more than this for.
You mean that there's more?
A circular supply chain.
What I'm not sure what exactly do you mean, or what is the question?
What I'm saying is, the transformation events. There are several types of supply chains. Okay, there is a traditional linear one, and then the circular one.
Yes.
So when you talk about holistic, I was expecting that you will extend it to a circular supply chain.
Ah, okay. Yes. Yeah. Now I know what you mean. What is actually a very important aspect of our research, and this is what we're also currently doing. We are developing a holistic approach. And what is a very important aspect is that we classify supply chain events. What kind of supply chain events do we have, and how we can include them? And also then, of course, there's the question, where are then the limits? Because it's probably impossible to include everything. Yeah. But this is one part. Actually, we have not considered at the moment like the whole, like a circular economy.
Yeah.
This is because this is then extremely complex actually. But we will
I think it's an important part of it actually.
Exactly. This is then what you can do when we are done with mapping, like once from the beginning to the final product. Then the next step is how to do it like backwards, basically.
Yes.
Yes.
Okay,
but this is part of our research actually.
Okay, thank you.
You're welcome.
Okay, Fabian, thank you again. Let me just check if we have additional requests for intervention. It seems that we don't have additional questions. So thank you very much again for your presentation. And to the last presentation, which is LISC model, LISC, an innovative paradigm for liquid supply chain, paper number 108. The presenter, I suppose, is Mariacarmela Passarelli. Mariacarmela, can you confirm?
Yes. Yes, I'm here.
So you can share your screen. And
I'm trying to share.
Yeah, we can see your screen now.
Do you see my screen?
Yeah, and we also see you. So you are allowed to start. You have 15 minutes for your presentation. Thank you.
Okay, thank you very much. I'm sorry, but at the beginning I had some problems with Teams, so I just arrived a few minutes later. I'm very sorry. And good afternoon to everybody. I'm Mariacarmela Passarelli. I'm a researcher at University of Calabria, and I would like to present this starting point of a big project that I'm leading with Giuseppina Ambrogio, Luigino Fidice, Alfio Cariola, and Vincenzo Sterfalaci. They are from University of Calabria too. The name is LISC Model, an innovative paradigm for liquid supply chain. We started this project during the first pandemic period. And we started from the definition of supply chain, and we started to think about possible issues related to supply chain. We all know that in this period, product life cycle is becoming very shorter and shorter. And the volatility of demand is increasing because there is an amount of uncertainty. The competitive environment is changing in many sectors, and there are occurring a lot of external problems, external shocks like COVID. And then we started to think about what was happening during the COVID period. And in most of the sector were characterized by the increasing of demand for some products. For example, we think about facial masks. and masks. In other sector, there were a lot of problems related with the fail of the sector. And so most of the firms will have to survive. So we think about possible needs of firms. Possible needs are related with the introduction of digital transformation, the disintegration of the process of the supply chain, the increasing amount of knowledge and technology, and also another important element related to open innovation, because most of firms started to think about the open innovation paradigm. So to deal with knowledge, machineries, technologies that are not owned by firms, but owned by external actors. This to react to exogenous shocks. So we defined two research questions. The first research question is, which technologies and knowledge should be owned by a firm itself, and which it buy on the of innovation? And then, which is the level of integration that firms should develop between themselves and their suppliers? So we started to think in the paradigm of open innovation. Then we started our research with a review of the literature, a state of the art, and then we tried to match the paradigm of open innovation with the supply chain in the perspective of digital transformation. So we started, of course, with a literature review, and considering all the models of supply chain that the literature proposed, stemming from the state of art, we propose a maturity model for supply chain that considers viability, reactivity, resilience, and anti-fragility, because that were the main elements that firms asked during the first round of COVID-19. So we started with an empirical analysis. The empirical analysis was led on a sample of Calabrian firms. Firms belong to the smart manufacturing sector. Then we deal with a qualitative analysis, trying to explore the needs of firms with supply to external shock. So we consider this empirical analysis, and we interviewed some managers of firms, and we get information from 21 managers. The managers explained us their needs. Their needs were related to customization, availability capacity, technology availability. They have a lot of technology, but they need to create new products, and they need to co-develop with other actors because they are alone sometimes, and they cannot develop all the products that they want within the boundaries of the firms. Then we consider within these 21 firms all their technologies, all their machineries, and they declared 101 machinery that were able to share with other firms within the region context. So it was an interesting result for us, mainly because some of the planes of the firms are oversized, and frequently they are not able to exploit all the machinery they own. At the same time, they lack some machineries that they need to exploit in order to develop new products or to gain a competitive advantage. So they proposed us to create a kind of virtual catalog of regional machinery and technology in order to promote cooperation and to survive to this shocked period. And we consider a new, stemming from these results, then we consider a new paradigm for supply chain that we called, according to Bauman, liquid supply chain. That is a new supply chain, is not a rigid supply chain, but is liquid and can change according to the external shocks, considering the anti-fragility, the reactivity, and the availability of the supply chain. So it's a new model that considers the open innovation paradigms, because when firms are not able to deal with problems using machinery and technology, of the boundaries, and when they have a lot of technology that are not unused, they can offer to the external context the technologies and the machinery that they own. So we consider also a mathematical representation of the model, even if it is a very starting point, because we need to add also some constraints related to cost, for example. But it was just a first representation of the model. Which are the main characteristics of this LISC model? It's an open innovation model based on a networking, based on nucleus of technologies. It's a kind of supply chain able to share nucleus of technology as a micro level entity. I cannot make a network between firms, but between nucleus of technologies belonging to the firms. So this improves some performance of firm, like viability, resilience, and fragility, reactivity, and increase the customization for firms, and increase also the product innovation rate that is related to the necessity of firm to adapt and to react to external shocks. And this, of course, generate this, the improvement in some operational performance. So this is what's happened. For example, we studied what's happened in Decathlon during the COVID period, and it is perfectly coherent with our model. So just to conclude our proposal, this is a new model, is an advanced model that is technology, but the virtual element of the technology is a supply chain, let's say, in cloud, and it's able to lead the firm to answer to external shock, just to satisfy market condition due to shock, to external shock, without decrease the performance, the operational performance, and also the general firm performance. Next steps, of course, are already, we are already working on testing a model on a large sample of firms in Italy. That's all for our paper. Thank you very much for your attention.
And thank you for your presentation. We have some minutes for questions. So is there any question from the audience? I can't see any request for intervention, so I have a comment, if I may ask you.
Yeah.
Just to discuss a little bit. You started your presentation mentioning COVID and other risks and disruptions and so on that can happen in a supply chain. My question is about let's say, added value, the newness of your approach compared to traditional risk management approaches, which are quite numerous in literature. Can you comment on that?
Yeah, because it's from the state of art, for example, we examined a lot of model of supply chain. For example, the underground supply chain. The main point in this paradigm that we consider is a kind of dynamicity of supply chain. If the, for example, that consider the relation between single nucleus of technologies with RL nucleus of technology that are owned by other firms. And this kind of network is changing by adapting to the external shock and to the needs of market that the firms are asked to satisfy. So it's kind of, it's the model that is different, but the concept underlying the model is, of course, coherent with the traditional concept belonging to the literature, of course. Yes. What is important is the underlying element like reactivity, anti-fragility, and viability, because if you change the supply chain and the relation among nucleus of technology, you have to think about, consider the anti-fragility, reactivity, and also other, for example, economic constraints like costs, for example. So this is the main point. You have to satisfy anti-fragility, reactivity. Okay?
Okay. For me, thank you.
Welcome.
It seems that we have no more questions from the audience. So thank you again for attending this session. Last presentation. We are invited to attend the award ceremony and also the closing ceremony of the conference. And I hope you enjoyed this session and also enjoy the rest of the conference. Bye.
Thank you very much.
Thank you.
Thank you very much. Thank you. Bye-bye.
Bye.
Bye-bye. Thank you.